Hello there, welcome to lesson number 7 on our series on creating bracelets using FluidDesigner for 3D printing. In today's lesson we're going to show you how you can use just a simple cylindrical mesh to create a bracelet. So if you start off FluidDesigner, we need to go to Learning Projects, Jewellery Projects, Bracelets. And we're doing lesson number 7, so we just need to scroll down to 07, which is a simple cylinder bracelet. Now if I just switch on the screencast keys, any key presses I make should be displayed in the panel here. And this is what we're going to create. It's just a very simple bracelet using a cylinder. So as is normal, the help window here shows you all the instructions on how to actually create this bracelet. So if you don't want to watch the video, you can just work through the instructions there. So what are we going to do? Well, we're going to add a mesh and then a cylinder. So add mesh and then cylinder. Now at the moment this object is, as you can see, is really quite small. So what we need to do is we need to go to view and zoom to selected. And so there's our default object. Now it's only 2mm by 2mm by 2mm. So we are going to have to modify this. We're also going to have to delete the top and the bottom of this cylinder. So what we need to do first of all is if we go to view and view the object from the top. Okay, so we're looking down on it now. Now it looks a little bit odd, the bracelet at the moment. That's because we're in perspective mode. We're in top and perspective mode. If you want to change to ortho mode, this option here is a toggle. It switches between perspective and ortho. So you notice the original bracelet is removed there when we do that, but as you can see it now looks a little bit better when we're in ortho mode. So let's just zoom in on the new object today, and I'm just scrolling the center mouse button to zoom. What I want to do is I want to delete the top and the bottom of this object. So in order to change anything in FluidDesigner, we need to go into edit mode, and we go into edit mode by pressing the tab key on the keyboard. And it'll tell you in the toolbar at the top there, you're in edit mode. So tab key goes into edit mode, tab key comes out of edit mode, so you can toggle between the two. Now at the moment you can see that if I just rock the object, all of the object is currently highlighted. We don't want all of it highlighted, we just want to delete the top and the bottom of it. And the A key on the keyboard, A selects all and A deselects all. So I need to deselect all of those faces at the moment. We are in face select mode at the moment, so in other words, if I click, I can highlight the top face there, and nothing else is highlighted at the moment, just the top face. So with the top face highlighted, I can press the X key on the keyboard and delete the top face. We can now see inside this object, whereas you can also see there's another face on the bottom. So we need to highlight that face on the bottom and press X on the keyboard and delete that face. So there we are, we've deleted the top and the bottom face of this object. So if we just go to view and view it from the top now, that's the object that we've got. We're currently in edit mode. What we need to do now is to come out of edit mode, so we can press the tab key on the keyboard. And if we just zoom in on this object again, you see this object is a really thin shell at the moment. It's got no thickness whatsoever. And also it's actually a lot smaller than the finished object. So if we just go to view and view from the top again. So the next thing I'm going to do is I'm going to scale this object up so that it's more like the size of the finished object. And we can scale in FluidDesigner. First of all, I would suggest you point the mouse at the center of the screen, then press S on the keyboard and just move the mouse away, and you can scale the object up. And if you look in the dimensions panel over here, you can see the size that it's scaling up to. So if you wanted a bracelet that is 50 millimeters, you could scale it up to 50 millimeters. Now that's close. It's not easy with the mouse to get it exactly right. So you could click at 51, and then if you go to X, Y and Z and type in 50 millimeters in each of the values, that will give you an internal diameter of 50 millimeters. Now whenever you scale in FluidDesigner, you're always going to end up changing these vector values here, the scale factor, in the toolbox window. So I opened up this window by clicking on the plus sign at the top, or alternatively I can press T on the keyboard. These values must always be at 1. Whenever there's a value for X, Y and Z there isn't 1, you must reset the scale. And you do reset the scale in FluidDesigner by holding down Control and pressing A, and then selecting Scale. And as you can see in the panel there, just the scale is now ticked, and so that's back to where it should be. That's just one of the peculiarities of FluidDesigner. Now we've set a Z value of 50 just to keep it in same with the other ones, but that's actually much too large, so we're going to change that in a minute. But at the moment this is a thin shell, and we need to give it some thickness, and we do that in FluidDesigner. In the Properties panel we go to the modifiers, and we're going to add a modifier, and we're going to add a solidify modifier. And if I just open up the properties window slightly, you'll be able to see that the variables that I've got in here are the thickness, and you can see if I click there I can change the thickness. Now we want a thickness of about 2 millimeters, but we don't want to apply the thickness on the inside. If we apply the thickness on the inside, we're going to end up changing the X dimension. It says 50 millimeters there, but once we've applied this thickness of 2 millimeters on the inside at both sides of the object, the inner diameter will be reduced to 46. We don't want to do that. We want to keep the inner diameter at 50. And the way we can do that is we can change the offset. At the moment, -1 offset means here's the original shell, this is the line of the original shell. -1 means the offset thickness is applied on the inside of the object. This 2 millimeters is on the inside. I want to put the 2 millimeters on the outside, and I can do that by changing this value, changing it to +1. This was the thin shell before we apply any thickness. +1 puts the thickness on the outside. So our object now should be 50 millimeters on the inside and a thickness of 2 millimeters. Now we want to apply this, and the way to apply it in FluidDesigner to confirm the thickness once you're happy with it, and you don't want to change it anymore, so you go to Tools, Objects, and you convert it to a mesh. So there's our object now. The only thing what we really need to do now is we need to change the height of this object. So if we go to View, and if we view it from the front, okay, what we want to do is we want to change the height of this. Now you can do it in a number of different ways. We could just change this value here. That will resize it. An alternative way of doing it, slightly trickier way in some respects, but it's worth understanding this, is we could use the scale factor. So if we press S on the keyboard to scale, now at the moment you'll see I'm scaling the whole object, so X, Y and Z are all changing. But if I want to scale just in one axis, so the blue line here, the vertical blue line is the Z axis. If I want to just scale in the Z axis, after I press S for scale, if I press Z, what that does is it restricts my scaling to just the Z axis. So you can see only Z is changing now. X and Y are fixed. So I can rescale this, and I can scale it down to, I think about 10 millimeters we're going to do it, yeah. So there's 9.9, and then obviously if you want you can actually type in 10 millimeters there. Now again, we've scaled it, so whenever we scale it we need to open up this properties panel, and we see that these vector values are not set at 1, So we need to apply the scale, otherwise we'll have problems printing. So if we hold down the control key and press A, and again apply the scale. Okay, so there's our object now. Now we've made it as 50 millimeters internal diameter. If you wanted to change that, you could do S for scale again, and you could increase the diameter to 60 or 65 millimeters, or you could even reduce it down to 45 millimeters if that's the internal diameter you want. Let's just show you how you can actually double check the internal diameter. First of all, I'm going to delete the original object because we've now got a new version of it. So I'm going to highlight it and press X to delete. If we want to measure the internal diameter of this, we can always use the ruler. So if we go to View and Top and scroll along and click on the interactive ruler, we can roughly measure the internal diameter of this, and we can see that, yeah, it is about 50 millimeters. A better way to do it is to zoom in. The larger the object, the easier it is to measure more accurately, and try and measure across a line like that. So 49.8 millimeters, that's pretty good. That'll suit us for today. So now what we want to do is to save this, and as is usual in FluidDesigner, we always recommend you go to File and Save As. Go up through the menu system and look for the folder My Projects, Jewellery Projects Bracelets, and it's lesson number 07, and it's a cylinder bracelet, and you save that as a Blender file. Now we can't print Blender files, so you need to save this in a format that's printable, and also you need to check that file. So we recommend you go to File, and we always export ours as wavefront objects. It's just our habit, and we're going to save it on the desktop. So it's 07 cylinder bracelet, and this time it's an OBJ, an object file, and that's a printable file format, but we wouldn't send that straight to the printer. We'd always start up the application Netfab Basic and go to Project and Open, go to the desktop, open 07 cylinder bracelet, and let's see if there's any problems with it. Well, there's no warning red triangle, so that's a good sign. But what we would recommend is that you still go to Extras and repair the part, and you'll see that Netfab has triangulated the mesh. These lines here, these diagonal lines, have been added by Netfab, and on this face as well, and the bottom and the back faces, because that's what the printer is looking for. Now if I just click on Update here, you can see that we've got no border edge problems, no orientation problems, no holes. We've got one shell. Even so, still run the automatic repair to triangulate the mesh and execute it, and also apply the repair and remove the old part. Very simple procedure in Netfab. We haven't come across any problems with this particular object, but in other objects you will find that there are holes and border edge problems, and you will find Netfab fixes it. So now all we need to do is to go to Part, export the part as a wavefront object, export it to the desktop, and it's 07 cylinder bracelet, and it's repaired, and this is the file that you would print. Okay, thank you. That's the end of this lesson today.